Hello again. My name is Asen. I am a consultant with MariaDB Professional Services. And I have just taken off the robe of Salvatio. So now I'm going to assume a more humble role and just be your guide in the next 20 minutes or so in the world of high availability and MariaDB. So high availability. You can hear these words a lot when it comes to modern day computing systems. But what is high availability really? And how does this translate into our database? How does it impact our database? And what can we do to make it work even better for us? Let's first try to demystify a little bit what high availability is. By definition, a highly available system is a system which aims at an agreed service level. The word agreed is particularly important here because, as we're going to see, the higher this HA level that we aim at, the more complex and expensive a system becomes. So we never want to over-engineer a thing. We always want to stay within boundaries which make us happy. And this means that in order to talk about high availability, we need to put forward some definitions. We need to put some good measurements of what high availability is. Let me start with an example. I guess most of you have a golden ring on somewhere on your fingers. And maybe some of you know that the amount of gold in your ring is perhaps just 3/4. So if I tell you that I have a golden ring for you, which is 99% pure gold, you would likely be pretty happy with this. But is 99% really good for our database? Let's put some numbers in. If your database has 99% availability, this means that your database will still be absent for about 7 to 8 hours every month, which can then accumulate to a downtime of about 4 days a year. Now imagine your website powering an e-commerce website, and imagine your database being gone for 8 hours on a Black Friday weekend. Naturally, this is going to be a complete disaster for your business. So along these lines, you can easily guess that 99% may be a good thing for golden rings, but is not a good thing for a database. We need to aim higher. How much higher? What about 3 nines? This would be 99.9% of availability. This translates into about 45 minutes of absence per month, or on an accumulated basis, 8 hours a year. This is still not that much, but also not that little. It mostly depends on how mission critical your database is. Nowadays, most databases power multiple applications, so 1 hour of absence may still be too much for a particular system. If you're guiding your rocket towards the moon, you don't want your database to be absent for 45 minutes, right? So 3 nines may also not be enough in certain cases. Then what about 4 nines? This translates to downtime of just 5 minutes per month. Is this good? Is this bad? Well, consider it this way. Databases run in operating systems, and nothing in the software world is perfect. So we need to, from time to time, apply software patches, fix bugs, and restart our systems. How long does it take to restart the database? Well, if you're on a bare metal server and you have a big database, it can easily take up to 5 minutes to reboot the box, not taking into account the fact that all of your caches will be purged. So you're going to start with a database with nothing cached in memory, and it will be slower than usual. And it turns out that a single maintenance cycle can eat up all of your allowed downtime for a given month. But what if you have to do your maintenance twice a month? What if there is an emergency fix that has to be applied? Are you going to sacrifice your SLA for this? Is there a way out of this situation? We're going to see this in a moment, but for the time being, we can easily conclude that the more nines you want to have, the higher your cost becomes. And with this thing, we can try and take a look at high availability for databases. How do we solve the problem of getting above what a single database instance can offer us. A common solution to this problem is to have more than one database instance and keep these database instances synchronized or replicated. In this case, should need be, you can substitute your main database with its replica and then do whatever work you have to do on the main database. And this way, you can mostly avoid the prolonged downtime that otherwise would be inevitable. Now, theoretically, this sounds like a good thing to do, but it comes with a number of problems. First, of course, there'll be some standby database using up hardware resources, consuming electricity, and doing nothing. Obviously, a waste of resources. The second thing is that you still need a clever person to switch these databases at the appropriate moment. And this clever person will be your database administrator. And this process of switching databases is a fairly stressful one. You know, database administrators hate this because any single mistake you make at this point can compromise the process and you can end up with downtime on your database. So even if you have a smart person who knows what to do, it's still not a 100% comfortable situation. So let's for a moment think, what if we substitute this stressed person with a piece of clever software that will feel no emotions and will do exactly what it has to do at the appropriate moment in time? We'll see this piece of software just a few slides from here. But one thing to take away from this slide is that whatever the HA level that we aim at, there's always a projected outage. So by definition, when you say high availability, your business people hear outage. So can we then do better? Can we go completely without this outage? For this purpose, let me introduce another concept. The concept not of high availability, but the concept of continuous availability of your database. And put it into this perspective, do you fancy a good night's sleep? Do you hate late night text messages telling you that your database is misbehaving and the performance of your application is compromised? I personally hate this, and I'm sure most of you do. So what is continuous availability then, and what does it give us? Continuous means without interruption. So we're trying to imagine a world in which the database will operate without interruption of its service. This is an important distinction we have to make. We're not trying to build a database which never fails. Hardware does fail, software does fail. Sometimes bugs have to be patched. So the failure is not the problem. The problem is to cope with this failure in a good, graceful manner so that our application will not suffer from this. Knowing this, we can try to define our imaginary perfect world in which we can go through several steps. So first of all, imagine that a database is capable of handling its own failures. Wouldn't that be nice? Wouldn't it be even better if this failure will not affect the application, so the application will not see any impact from a change in the topology of a database? Yes, it will be better, but there's still more to this. It will even be better, it will be the best possible situation, if such a change in the database topology will not require at all any change to the application side. So the application will stay completely ignorant of the fact that something unexpected happened on the database side. In other words, our imaginary world will achieve the DBA's holy grail, that is, to have a database manage itself automagically, and of course, for the DBA to wake up in his own bed at sunrise. But is this really possible? Isn't this just a mission impossible? Well, let me introduce you MarkScale. MariaDB MarkScale is a piece of software that was created a few years ago by the MariaDB people with a specific purpose of taking the place between the clients and the MariaDB service. As you can see on the left of this diagram, it sits in the query path. So the clients no longer connect to the MariaDB service directly, but they connect to MariaDB MaxScale. And in turn, MaxScale is the one that connects directly to the databases. And by sitting in between, it can assume a multitude of interesting roles and can do a number of cool things that normally are not possible without an intermediate agent. For example, MaxScale can assume the role of a firewall. It can now decide whether a particular query should be let through or it should be declined before even reaching the database service. This way, for example, you can build some throttling mechanism that will protect your scarce and precious resource, the database, from a denial of services, be it intentional or just unintentional because your load is getting too high. It can also protect your database, by the way, from nasty SQL injections, which are a fairly unpleasant and common way of stealing data from your database. But there's more to the story. Because MaxScale sits between the clients and the servers, it knows about the MariaDB server topology. And this way, it can assume the role of both a router and a load balancer. By becoming a router, it can direct a query to the most appropriate server that will be the best target for it. For example, if this is a writing query, an insert, update, or delete, it can be directed to a writing server, a server which accepts writes, while if this is a select query, it can be sent to a server which only accepts reads. This way, MaxScale becomes both a router and a load balancer. Because MaxScale was purpose-built, it knows a lot about your database topology, and it does constant monitoring of this backend service. This way, MaxScale can know if something changed in the backend state. For example, if a particular node goes away, MaxScale is capable not only to understand this change, but to actively influence what is happening in this MariaDB cluster. This way, MaxScale can effectively do the same thing that your DBA do, but without the stress on the DBA, without the risk of mistyping a command, and faster than a human could do it. Let's take a look at a couple of scenarios. Suppose we have a primary server and two replicas. This is what we see on the left. And on top of this, we have our MariaDB MaxScale instance. Suppose now that we need to do some work on the primary node, and the node has to be taken offline. With the help of MaxScale, this situation can be resolved transparently and quickly without the application noticing anything unusual. See how it goes. First, the primary node becomes unavailable and there is nobody to serve write requests. Second, MaxScale notices this and then goes to all the remaining replicas, inspects the state of these replicas, and chooses the one that is the best candidate to become the new writing node, the new primary server in the cluster. Then MaxScale promotes this replica to be the new primary. This happens at stage 2 in the middle of this slide. And then on the right, you can see that MaxScale will automatically join all the remaining replicas to this new primary node. So MaxScale is going to conduct what we call failover and is going to do it automatically in a safe way by choosing the best possible candidate and without any chance of mishandling this operation. But there is more to this story. What happens when your old primary node comes back online? Should it just sit on the side and wait for a DBA to do something with it? No. MaxScale can automatically detect that a former primary is now available as a standalone node and can join it back into the cluster as just yet another replica. This way, MaxScale helps maintain the node count on your server, and you can effectively cycle through the nodes, providing you with continuous availability. But what if you have a different type of cluster, not a primary replica, but a fully synchronized cluster, like the MariaDB cluster? In this case, MaxScale can also understand the topology of the cluster and handle any situation that needs active action. Let's say that we have 3-node, fully synchronous replicated cluster. MaxScale will still designate one of these nodes as its primary writing node, and the remaining nodes will be only used for reading. As you know by now, we do this because the capacity to ingest data of your synchronous cluster is always equal to the capacity of a single server. Therefore, there is little use of spreading the writes to multiple nodes. But what if the writing node goes away from this cluster? Because the cluster is fully synchronous, it will maintain its integrity, and the absence of one node will not compromise its work in any way. But MaxScale will immediately detect the absence of the former writing node, and will simply choose another node to become its writing node. This way, MaxScale responds to the failover event that occurs inside the cluster and maintains the accessibility of this cluster to the client applications without them really knowing that something happened on the cluster. But as we said a few slides ago, there is something else that we desire. Remember, we not only wanted the databases to handle their own failures, we wanted the applications to see no impact of a database undergoing certain change. We wanted to do this without the need to modify our application whatsoever. So here is more to the story how MaxScale helps achieve all these goals. First of all, if you just conduct a failover, this will inevitably terminate all existing sessions. So all the clients will understand that something has changed and they need to respond to this change by reconnecting. This could put some strain on the applications. Not all of them may reconnect immediately. This is obviously not good for the applications. What does MaxScale do here to help us? Because MaxScale sits in between the client and the database server, MaxScale will notice the termination of the server connection, but it will keep its client connection up and running and will bridge it to the next connection that MaxScale will establish to the newly promoted or elected node. This way, MaxScale ensures that the client will not see any interruption of its connection. So far, so good, but is this all? Unfortunately, no, because when a connection is established, the client typically wants to create some sort of a custom environment for itself. It may, for example, set a particular collation that it wants to be used by default on string operations inside the database. Or it may set certain values by name to later refer to these values by this name. So if we just connect an existing session to some other newly promoted server, all these settings will be missing. So the client will not see a connection interruption, but its session will not be in the state that it expects it to be. So obviously, not the perfect situation. What can MaxScale do for us? MaxScale is capable of doing a session restore, because MaxScale keeps track of the session since the moment it got first created. MaxScale is able to replay all the settings that were done on this session after the failover. And this way, the client will not only stay uninterrupted, but will also not encounter any change of its environment inside the session. Now, this sounds much better, but suppose that during the failover event, a client were in the middle of executing a transaction. You know how important transactions are to our world. We don't really want anything bad to happen to our data. And that's why we protect it with a transaction. It's either all or nothing. But if we conduct a failover, and even if we restore a session, this will still interrupt the transaction that was ongoing. And to be honest, not all applications respond well to uninterrupted transactions. Most of them will just throw some sort of an exception and let some other layer handle this failure. You know, remember last time when you clicked a button on a website and you suddenly got another page saying, oops, something went wrong. Maybe it was the moment when the database experienced a failover and your transaction was lost. So what can MaxScale do here to help us? Well, MaxScale can completely replay an ongoing transaction on the new backend server, because MaxScale keeps track of everything that happens inside a session. This way, even if a transaction was ongoing and a failover was conducted, MaxScale will start replaying the transaction on the new backend server, and the application will never notice any change in the topology, any change in the connection, any change in the session, or any change in its transaction. And by doing so, MaxScale can ensure a completely seamless failover in a way that no changes are required to your application to support any kind of outage or failure. And this way, MaxScale achieves our goal. It achieves the goal of giving us continuous availability of our database without the need to alter anything on the application side. Thank you for listening to this